Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Rahman Farhan binti Ahmad, matric number CF180092. We are from Group 10. We present about our project group by using software Hec-Ras.
Our group will present about introduction, literature study, methodology, result discussion and conclusion.
The introduction of Hec-Ras. Hec-Ras are acronym of Hydrology Engineering Center's River Analysis System, which is one-dimensional hydraulic modeling program. There are types of analysis include steady flow models, unsteady flow models, sediment transport models, and also water quality analysis. Next, to compute the water surface profiles, which assume a steady, gradually varied flow scenario, and the direct step method. The importance of study, first, to help engineers making decisions and stimulate the design. Second, freely distributed, integrated system software designed for interactive use in a multitasking and multi-user network environment. Third, to improve the potential, easily simplified into one-step process without necessitating the time-consuming transition merely. There are three problem statements. First, water overflow to the bank, which is by using drainage alloy. And second, the several channels need to be modified. And third, the elevation and the bottom width modification. Our objective of study are to perform a steady flow analysis using Hec-Ras software, and then to determine the feasibility of Hec-Ras to sufficiently analyze the effectiveness of the drain. Lastly, to overcome the overflow of the river and to provide suggestions to solve the flood by section modification. Thank you.
My name is Niza Ashraf bin Supri, matric number CF180055.
I will present about the literature review. We are using case study example called Upper Thames River Basin. This study are showing the investigation of flash flood problem and describing the case study which is impact by climate change. The methodology that used in this case study are pre-processing of geometric data for Hec-Ras by using Hec-Ras, hydraulic analysis and model development in Hec-Ras, and the post-processing of Hec-Ras result and fluid plan mapping using Hec-Ras. The problem statement for the case study are the flooding problems which always occur under the environmental climate change, and the historic climate data information in public management also not suitable and appropriate. This case study also propose a problem solution which are climate modeling using original weather generator model that give long sequence of meteorological variable factor for chosen to set off climate change situation.
Hi, Assalamualaikum. My name is Masyafiqah bin Muhammad. My matric number is 18010. Now, I will present about this methodology. The selections data type. It is a secondary data type. The collected data were used to obtain a series of cross sections along the stream, and the meanings value for each channel were given as follows, which is for channel 0 meter to channel 599 meter, the meanings value is 0.020, and for the channel 600 meter onwards, the meanings value is 0.040. The discharge is different for different change in years, which is 5 years, 20 years, and 50 years. This is the data for our group in Johor River tributaries started from downstream and until stream, which is for channel 1277.1 meter. The discharge for different change in different years also given for project. And the part of analysis is we are using a steady flow analysis. It is preferable because it used to model the movement of the water with slow changes of flow rate. Unlikely other natural disasters such as storm, flash flood, and surge. It is also suitable in this project to predict the floodplain of Johor River as the flow velocity and conveyance is comparatively lower than flow analysis. This is the Hec-Ras cross sections for coordinate. After we put the data in the Hec-Ras software, then it is automatically plotted. And this is the water level at the Johor River after we run the Hec-Ras software, and we can see the green line is for 5 years, 20 years, and 50 years. Before we run the Hec-Ras software, we have to set the downstream to critical depth at steady flow boundary conditions. And next, I will present about the results of this question. After we analyze those 9 channels, there are 5 channels which seems failed to overcome the flood and have potential with the overflow in 50 years in the future. Those channels are channel 700, and this is an example of channel 0 meter, channel 700, channel 1150, and channel 1477.5.
As a result, the modification that we have for those channels are to expand and deepen the channel. But in this project, we also try to modify other channel which is downstream so that the water will not overflow after 50 years. Table below shows the cross-section of each channel before and after the modification of the channel. These are the proper solution for channel 0 which is downstream. This is channel 300, channel 450, channel 550, channel 700, channel 900, channel 1150, channel 1300, and channel 1477.5. This is the channel design and modification alternative that we get and the data of cut and fill that we propose. So from the data, this is our perspective plot that we get from the downstream to the upstream. So the cut value in total are 24,087 meter cube. As a result, all channel has been modified to prevent the overflow of water in the next 50 years. The channel have been modified by expanding its bottom width and deepen its elevation. The total cut for allo A for modification is 24,087 meter cube. The excavation rate based on the Department of Irrigation and Drainage is 5 ringgit and 70 cent meter cube. So the estimation cost for this excavation is 137,295.60 cents. So for the conclusion, the channel modification for the flood problem and overflow of water at Johor River could be overcome, and it could hold amount of water over the period of 50 years in the future. The river cross-section also could be identified easily and have better understanding about the hydraulic at Johor River. Common geometric data representation and common geometry and hydraulic computation routine have been familiarized by regular practice of using Hec-Ras. Our suggestions are to consider adding more cross-section to the model to achieve more accurate result. If the additional channel cross-section data has been obtained, the appropriate of manning and value should be created in high resolution for the whole area of Johor River. Manning and value then could be automatically assigned to each cross-section. So that's all from our group 10, section 10. Thank you.